Good morning, friends. Let's cover chapter 10 on pair RDDs. So, in our previous chapter, we have learned about tuples. So, tuples were a collection of elements, just like a list that we have in Java. Similarly, in Scala, we have got tuples. But the only difference that we learned in tuples in Spark is that we can have different type of element types, and we can have a maximum of like from 20 to 22 elements in that tuples, each of having maybe string, integer, or any other custom type. It need not to be same type for each of the tuple elements. So that's what it has been missing in Java for a long time. So for our tuples, we already have one tuples which can contain like 22 elements of different type maximum. We can have 2, 3, 4. But in Spark context, right now we also have a concept of this pair RDDs, which is just a pair of two tuple objects. So it's very much similar like we have got hash map in Java. So in hash map of Java, we have got a key and a value. But the only difference between the pair RDD and the Java hash map is the key should be unique in Java hash map. But in case of pair RDD, it's not necessary. We can have duplicate keys. So for example, in our previous chapter 9, where we are learning about tuples, so we saw that we can create a Java RDD, which can have each element as a tuple2, having two values, string and integer. Similarly, we can have various different type of Java RDDs, which can be tuple3, which is 3 elements here, tuple4, tuple5, till tuple22. The limit is to tuple22. So the idea is that in this Java RDD, each element can be as many number of tuple types. So what was the need of creating this pair RDD? We could just use the Java RDD. For example, in this case, as we have seen, we can just create a Java RDD and we can have a similar tuple to each element. But what was the need for having this pair RDD? Java is called as JavaPairRDD JavaPairRDD as opposed to Java RDD. So the need for this was that there are some special functions which can be applied on this JavaPairRDD, which is not available on a generic JavaRDD having any type of tuples. It's only available for a JavaPairRDD. So the most common ones are distributed shuffle operations, such as grouping or aggregating the elements by a key. Guys, this is important, by a key. So for example, as we just mentioned that the pair RDDs, which we having a key and value, like one tuple element as key and one tuple element as value. And this key can be duplicate. And then because our RDDs are like extending across multiple slave nodes, it is partitioned across that. And then if we want to have any group by element, group by a key, or an aggregate by key, or reduce by key, these are all called as shuffle operations. So these are all those operations which are very much specifically created for Java PairRDD class, not for Java RDD. So as we see here, this wider transformation in which we have got this RDDs like accepted, spread across multiple partitions, like partition 1, 2, and 3, and 4. So when we call this group by key and reduce by key operations on the Java pair RDDs, so there is a shuffling of data across partitions. So this shuffling is called as a wider transformation, which means that it's not only like one partition where we are doing any transformation or action. That transformation, that is group by key or reduce by key or any other aggregate by key, this would be shuffling the data across multiple partitions. This is different than the narrow transformation that we have learned before, that, for example, is map, filter, and union operations. These are narrow transformation. It means that the data is not shuffled across partitions. The map, for example, if you do a map on this one partition 1 or 2, that map or filter will only do whatever the data is there in this partition and then create a new RDD with the new partition with the new map value or the filtered value. So data is not like it's not shuffled across multiple partitions. It's just partition 1 to partition 1. But in wider transformation, as we discussed, that the data is shuffled because we are using this group by key, reduce by key, which is only specific to the Java pair RDDs. So again, if we go back to our Spark APIs, so there are like set of transformations, and you can see here in this documentation that they are given that and pair RDD functions ASAP. There are some RDD API doc, which is on Java RDD, and this pair RDD as well, which is Java pair RDD. There are these transformations possible. And all this, which ends by key, for example, group by key. This is always called on a data set of KV pairs. So reduce by key is again on the KV pairs. By KV pair, it means JavaPairRDDs, not JavaRDD. Aggregate by key, sort by key. So these are like all transformations. And then we also have got actions. So there is one action called as count by key. This is again available on types RDDs of type KV, which is JavaPairRDD. So any by key functions, all those like functions like transformation and actions, which ends with by key, that are only applicable to PairRDDs, JavaPairRDDs. Let's go back here. So as we already discussed the difference between a Java map. So let's actually have a very basic example here. So PairRDD is like this. For example, we have got a key and a value, and we have taken it from a log. So we know that for the log level, we can have info, warn, error, etc. And if we are storing it into a PairRDD, so we can have duplicate keys here. For example, we have got an info here, and the value is another tuple of string, which is application started, completion in progress, for example. Similarly for warn and error. So this is like a very generic example of a PairRDD, where the keys are duplicated with having multiple values. And now we can call all those like group by operations. For example, group by key. For example, we want to like group by info or group by warn. We can do aggregation by key or reduce by key. So these are like specific operations which are required for PairRDD, and that's why we have got a separate class in Spark just for handling all these type of group by functions by keys using the JavaPairRDDs. Again, let's look at one very simple example that how it actually works. For example, we create this se.txt file. We have got a data.txt, and here this lines JavaRDD is created. This JavaRDD will have all these like elements of this file, and then we call this lines to dot map to pair. Now, when we call this map to pair method on the Java, this is JavaRDD, and then we call this this method here map to pair, and we are creating this new tuple with one as string and another word as a count. And so we are just mapping from string. Say string is one tuple one by key, and the value is long. And then once we get this JavaPairRDD here by this function, this returns JavaPairRDD. Then we can call this reduce by key function where we will do the sum. So essentially, it is like counting the number of words or the lines by using this method. So here we are using this part lines is JavaRDD, this pairs is JavaPairRDD, and then we call this reduce by key to calculate the count. So this is a very basic example of reduce by key using JavaPairRDD. Similarly, we can have several other methods which we'll learn in the unit test cases. So enough of theory now. Let's jump into IntelliJ and write some unit tests.